Hello and welcome to the Fossil Huntress podcast. On today's show, we're going to dig a little bit deeper into geologic time and build on the work of William Smith. So William Smith was the fellow who did the geologic sequencing in England and Wales that he published in 1815, so a goodly long time ago. And his observations let us see that the deeper the rock, the older the rock, and those older species we don't see represented in the younger rock on top. So it helped us build out a contemporary idea around those deposits. And through those sequences, we were able to build out the geologic timescale. The geologic timescale in its early days was based on relative time. So folks like William Smith mapping England told us that some of the sedimentary sequences were older than others. So we had a relative age telling us that trilobites were older than ammonites and ammonites were older than oysters. And that was hugely useful in organizing the physical and biologic events of the past. But up to a certain point, we couldn't tell the exact age, the actual age. And it was our friends in chemistry that gave us that knowledge. So around 1895, we began to understand radioisotopic dating. So that's the method of dating rock based on radioactive isotopes. And I thought we'd talk a little bit more about that here. So we talked earlier about how we use the elements and their radioactivity to give us the relative age of rock. And so we use carbon for rock that's 50,000 years or younger. And we know that carbon has a radioisotope carbon-14. And this decays away at a set rate. So the older the rock, the less carbon-14 there is compared with the remainder of the carbon. For rocks older than 50,000 years, we use other isotopes that have slower decay rates. So we use potassium-40, which we know decays at a known rate to form the gas argon. And we use uranium for older rocks. So we used the atomic clock of uranium to date the Earth because uranium breaks down to lead over time. And so that's how we calculated that our Earth is 4.5 billion years old. So today we can observe radioactive isotopes within rocks and minerals, and we can see and measure that they emit radiation. And we can also observe that radiation decay. So as the parent isotopes break down, they turn into their daughter isotopes. So the rate of decay is constant over time, and we can measure it with precision. So if you know the rate of decay and you've determined the proportion of the parent isotope to the daughter isotope, so as a simple math equation, 5 minus 3 equals 2, 5 is the parent, and we've lost the decay of 3 and we get to the 2, the isotope of the daughter, we can see how much time has elapsed since the rock formed. And the rate of decay of radioactive isotopes is expressed as that isotope's half-life. And that's the half-life, the time in which 1/2 of the original amount of radioactive isotope would have to disappear or change into that daughter isotope. I've oversimplified that a little bit, but you get the relative idea. So at the end of the time measuring one half-life, 50% of the original parent isotope would have undergone decay. And then after another half-life, half of what remains, so 25% of the original, would have undergone decay. And after a third half-life, only 12.5% would remain, and so on and so forth. And so it is from this that we begin to understand the true and accurate date of rock. But this leads me to another book suggestion for you, because to understand the chemistry means you need to understand the elements, and to really dig deep, you need to understand the periodic table, which is both glorious in terms of human achievement, but it's a table full of stories if you read it right. So I'm going to share a book with you, The Disappearing Spoon, that I quite like, and it helps delve deep and make the elements and carbon and the periodic table real for you. one of the best ways to understand a topic, any topic, is to be engaged with somebody who's truly keen on their subject material. So I recommend Sam Keen's The Disappearing Spoon, and it's a true tale of madness, love, and the history of the world from the perspective of the periodic table of the elements. So it talks about the individuals and our great achievements over time and figuring out where the elements go. So the periodic table is a bit like a castle, and each of the bricks in the castle is individual and has certain properties. And over time, we've been able to piece those properties together and realize that each of them cannot be broken down any smaller. And through chemistry, we've learned about the elements in the world and what makes them up. And it is from the periodic table and the radioactive elements and the properties of potassium and carbon, uranium and lead, that we've been able to tease out and give exact dates to the fossil record. So I highly recommend that book as a little read. You'll delight in the science of it. And I read it from time to time just for the sheer pleasure of it, and I recommend you do too, because hidden within the elements are the stories. And it's those stories that help us to truly understand the science behind fossils and radiometric dating and just the way the world works. So I'll leave it there with that recommendation, and I'll talk to you guys again soon.